Assalamualaikum warahmatullahi ta'ala wabarakatuh. My name is Ahmad Irfan Hakimi bin Hashim. My metric number is 9190188.
Bismillahirrahmanirrahim. My name is Aisyah Zafira binti Muhammad Nasir. Metric number 9190199.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nurin Zulaika binti Rasli. Metric number 9190180.
We are from TMS0334 Group 5.
So today we're gonna explain to you how to answer the question tutorial 2, question number 5.
Okay, let's start with question number 5A. So from this question, we can know that the question is about young double slit experiment. So actually we can get the answer. We can easily get the answer with drawing the young double slit experiment. So first, we can from the question, we know we can get some information, which is D. Capital D is 2 meter. We know that D, capital D, is a distance between the slit and the screen. So we can write it here. Okay. Next, we get lambda is equal to 500 multiplied by 10 to the power of negative 9. So next, we know that the y10 is with central maximum, the distance between central maximum and the 10 bright fringe. We can imagine that have 10 bright fringe. I don't have enough paper to draw it, so we can imagine it. So from the question, we can come up with the equation with the formula. This is Ym equal to m lambda capital D over D. So from this information, from this value, we can substitute into the equation. So we can calculate and we get the D, small d is 2 times 2.941 times 10 to the power of negative 3 meter. So this is this distance between two slits. Actually, at the question, we know that there are some value that is not in SI unit, so we must change it into the SI unit, which is meter. So that's all. Thank you.
Bismillahirrahmanirrahim. So I will explain to you how to answer the question 5B1. So the question is asked us to explain what will happen to the interference pattern if the wave length of light is increased. So first we have the equation Ym equal to m lambda capital D divided with small d. Okay, so to answer for this question, we need this equation, and also we have to cancel out the capital D with and small letter d, because we will assume that both of this capital D and small letter d is constant. Okay, we just have to consider about lambda, the Ym value, and also the m value. Okay, so let's say I have two types of light wave with different wavelength. So the first light wave, it has the wavelength 1, and the second light wave have wavelength 4. Okay, so when we substitute this value into this equation, we will get that for the first light wave, the Ym is equal with 1, while the second light wave, the Ym is equal with 4. So from this value, we can create a picture to imagine what will happen to the interference pattern. So for the first light wave, because its value is 1, so the distance will be like this, between one wave, between one wave and the another wave, it is close, which is equal with 1. And for the second light wave, the distance between the first wave and the second wave is 4, which is you can see that there are difference of distance between two light wave. Okay, so that means when lambda is increased, therefore the Ym, which is distance between the central bright fringe and the first bright fringe, which is first bright fringe m is equal with 1, so is also increased. Okay, so when the Ym is increased, therefore the interference pattern will decrease. It means that let's say what I say when the interference pattern, okay, we have okay, this is the distance is 4. If we compare with light wave that have a wavelength 1, it will be like this. This is 1. Okay, so we can see that we can from here for the second light wave with the wavelength 4, we will get only 3 wavelength. We only can see 3 wavefronts on the screen. But if the lambda is small, we can see a lot of wavefronts on the screen. So therefore, the answer for this question, when wavelength of light is increased, the interference pattern will decrease, and the number of wavefronts that we can see on the screen, which is the dark fringe, is will become so lambda is increased, so therefore the number of wavefronts that we can see on the fringe is decreased. Okay, that's all from me. I hope you can understand.
Assalamualaikum warahmatullahi taala wabarakatuh. So I will explain about this question. This question asks about the experiment when it is done in denser medium. So in denser medium, the velocity of the light is decreased. When the C is decreased, so the lambda also decreased, and the F, the frequency is increased. So from this equation, the capital D and the small letter d is constant, so we can cancel out the d's. So when we insert the lambda, the decreased lambda, so we can get this y also decrease. So this is the distance between the central bright and the first white fringe. Okay. So the interference produced is higher and more white fringe appears on the screen. So basically, this question is contradicts with this question. So that's all from me. Thank you. That's all from us.
We hope that you will understand our explanation and you will get some input from our video.
And thank you for watching, and don't forget to like and subscribe.